Welcome. In today's fast-paced world of design and engineering, clarity, precision, and efficiency are not just goals, they are requirements. This presentation will explore how we can elevate our technical documentation by mastering the creation and editing of tables and schedules. This isn't just about organizing data. It's about building a seamless, integrated workflow that connects every piece of information within a project. We will delve into the core components that make this possible: the clarifying power of annotations, the absolute necessity of precise dimensions, the visual language of hatching, and the organizational strength of structured tables and schedules. These elements are the backbone of modern design documentation, transforming simple drawings into rich, intelligent models. Whether you are working in AutoCAD, developing complex models in Revit, designing mechanical parts in SolidWorks, or conceptualizing in SketchUp, these principles are universally applicable. By the end of our discussion, you will have a comprehensive understanding of how these tools not only improve accuracy and efficiency, but also ensure compliance with industry standards, ultimately leading to better project outcomes. Let's begin our journey from static lines on a page to a dynamic, interconnected system of information management that represents the future of technical design. Before we can schedule data, we must first understand how to label and describe it. This is where annotations come in. Annotations are the narrative layer of our technical drawings. They are far more than just random text. They are a structured system for communication, encompassing text notes, intelligent data tags, leader lines, and standardized symbols. Think of them as the silent guide for the manufacturer, contractor, or fellow designer who will interact with your work. A simple text note can provide critical assembly instructions. A leader line can point to a specific bolt and call out its part number and required torque. In building information modeling or BIM, tags become even more powerful. A window tag, for instance, isn't just a label. It's a dynamic link to a database of information about that window, from its manufacturer to its energy efficiency rating. The key to effective annotation is standardization. By establishing and using consistent text styles, dimension styles, and symbols, and organizing them on dedicated layers, we create a clear, unambiguous visual language. This ensures that anyone on the project team, regardless of when they join, can immediately understand the information presented. In a sense, annotations transform a drawing from a mere collection of lines and shapes into a comprehensive document that clearly and concisely communicates intent. If annotations provide the why and the what, dimensions provide the how much. They are the absolute, non-negotiable language of precision in any technical field. Every line, arc, and angle on a drawing must be quantifiably defined, and that is the fundamental role of dimensioning. These precise measurements are the critical link between the digital design and the physical world, guiding the machinist, the builder, and the assembler. However, simply placing numbers on a drawing is not enough. Consistency is paramount. Through standardized dimension styles, we ensure that every measurement across a multi-sheet drawing set is presented with the same text height, arrow style, and precision, making the documents easy to read and interpret. But the real game changer in modern software is associativity. In older 2D CAD, if you changed the size of a part, you had to manually find and update every single dimension associated with it, a tedious and error-prone process. Today, with parametric modeling in platforms like SolidWorks or Revit, dimensions are intelligently linked to the model's geometry. If you lengthen a part by 10 mm, the corresponding dimension updates automatically. This dynamic link is a cornerstone of modern design, drastically reducing the risk of errors, saving countless hours of checking, and ensuring that the final documentation is always a perfect reflection of the model. Drawings often need to communicate more than just shape and size. They need to convey materiality. This is achieved through hatching. Hatching is a graphical technique used to fill areas of a drawing with a pattern, serving two primary purposes. First, it represents materials. Standardized hatch patterns defined by bodies like ANSI and ISO act as a universal shorthand. A pattern of repeating diagonal lines might represent steel, while a stippled pattern could signify concrete. This allows anyone reading the drawing to instantly identify the materials of construction without referring to a separate note. Second, hatching is essential for creating sectional views. When we slice through a complex assembly to reveal its internal workings, hatch patterns help differentiate the various components that have been cut. The ability to control the properties of these hatches is critical. We can adjust the scale to make the pattern more or less dense, change the angle to distinguish between adjacent parts made of the same material, and even apply transparency to see underlying objects. Modern CAD systems also feature intelligent boundary management, automatically detecting the enclosed area to be filled, which greatly speeds up the process. Ultimately, hatching adds a crucial layer of visual information, making our drawings richer and easier to interpret at a glance.
We now arrive at the heart of our topic: tables and schedules. In any project of significant scale, you will have hundreds of similar components: doors, windows, light fixtures, structural beams, or mechanical fasteners. Managing the data for all these items is a monumental task. This is the problem that tables and schedules are designed to solve. They provide a structured, easy-to-read format for organizing this repetitive data. A window schedule, for example, will list every single window in the project, with columns for its type, size, material, manufacturer, and installation details. A bill of materials, or BOM, in mechanical design lists every single part, down to the last nut and bolt required for an assembly. It is vital, however, to understand the evolution of these tools. In traditional 2D CAD, a table is often a static object. You draw the lines and manually type in the data. If a design changes, you must remember to find and update the table yourself. This is where BIM and parametric modeling introduce a paradigm shift. In a program like Revit, the schedule is not a separate entity. It is a live report generated directly from the model itself. When you place a smart door object in your 3D model, its data is automatically added as a new row in the door schedule. If you change the size of that door in the model, the schedule updates instantly. This dynamic link creates a single source of truth, dramatically improving accuracy and saving an enormous amount of time. Creating a schedule is only the first step. To unlock its full potential, we must master the tools for editing and customization. Modern scheduling tools within CAD and BIM software offer a suite of functions that rival dedicated spreadsheet applications. At a basic level, we have robust formatting options. We can control text styles, cell colors, and borders to improve readability and adhere to company standards. We can merge cells to create clear headings and group related information together. But the real power lies in data manipulation. Imagine a schedule with 500 doors. With a single click, you can sort the entire list by door type, making it easy to see quantities. You can apply a filter to show only the fire-rated doors, instantly isolating critical information for a code review. The capabilities extend even further into calculations. We can add a calculated column to a room schedule that automatically multiplies the length and width to give us the area. We can then add a total row at the bottom that sums the area for an entire floor. This ability to perform calculations directly within the design environment is incredibly efficient. Furthermore, many platforms allow for interoperability, enabling you to export schedule data to Excel for further analysis, or in some cases, create a live link where changes in the spreadsheet can update the schedule within the model, bridging the gap between design and data management. Having powerful tools is one thing. Using them effectively within a robust workflow is another. To truly succeed, we must adhere to a set of best practices for integration and management. It all starts with organization. A disciplined layer or category system is the foundation of a clean project. It allows team members to control visibility, isolate specific systems, and navigate complex models with ease. This digital housekeeping is not optional, it's a professional necessity. Next, we should embrace automation. Repetitive tasks like creating specific types of schedules or applying company standards can often be automated using scripts or macros. This not only saves an incredible amount of time, but also ensures that tasks are performed consistently every single time, reducing human error. We should also leverage data extraction. The information within our models and schedules is immensely valuable. Tools that extract this data into formats suitable for cost estimation, procurement, or facility management extend the value of our design work far beyond the initial construction phase. Finally, and perhaps most importantly, is quality control. We must implement rigorous checking procedures to ensure there are no discrepancies between what is shown in the drawings and what is listed in the schedules. This alignment is critical. A mismatch could lead to incorrect materials being ordered or components being fabricated at the wrong size, resulting in costly delays and rework. A systematic QC process ensures that the single source of truth remains true. As we conclude, let's reflect on the journey we have taken. We have seen that modern technical documentation is no longer about isolated elements. It's about creating a deeply integrated ecosystem where annotations, dimensions, hatching, and schedules all work in harmony, all drawing from a central intelligent model. This integration is not just a technological feature, it's a fundamental advantage that redefines our workflow and outcomes. The benefits are clear and compelling. First, accuracy is significantly improved. By establishing a single source of truth in the model and dynamically linking all the documentation to it, we virtually eliminate the risk of contradictory information and costly human errors. Second, efficiency skyrockets. The automation of schedule creation, the associativity of dimensions, and the ability to make a single change that propagates across the entire document set saves countless hours of manual labor. Finally, compliance with project, corporate, and industry standards becomes easier to enforce and verify. By embedding these standards into our templates and styles, we ensure consistency and quality from the very start. The larger takeaway is this: our role is evolving. We are moving beyond being simple drafters of lines and becoming managers of information. Mastering this integrated approach to documentation is no longer optional. It is an essential skill for any architect, engineer, or designer who wants to thrive in the modern industry and deliver projects with the highest levels of quality and professionalism.